Our next speaker was named by Computer Magazine in 2017 Data Scientist of the Year. Yasmeen is featured as an inspirational woman in We Are the City and has been named as one of the top 50 data leaders in 2017 in Information Age. Please help me welcome Yasmeen Ahmad to the stage.
Good afternoon. I am honoured to be here among so many females. I must admit this is very different to the normal data and technology conferences that I attend. And I've also got the honour of being asked to speak today and share some of my insights around data and technology. So I work for a company, Think Big Analytics, and we're part of Teradata, and I look after a team of data and analytics members. So I come from an analytics background, from a data science background, having worked in academia, come into consulting, and now I have a team of data practitioners. Everything from the data scientists, the data engineers, architects, we have DevOps engineers, business analysts, all of the skill sets that we need in our hybrid teams today to deliver value from data. So what I want to do today is share with you some of my experience of working with businesses, with our customers, and look at how data has changed business. Data is evolving, but also how analytics is now playing that key important role. You heard a lot about AI this morning. How is AI changing the skill sets that we as analysts have, and how is AI changing businesses today? So I'm going to start by reflecting back on actually us as a consumer, because we can all relate as a consumer. We interact with businesses every day. We interact with the bank, we interact with retailers, with telcos. Everybody's got those mobile devices. And what's changed over time is it used to be that local economy where you would go into the branch, you would go to the retail store, you would be speaking to your telco operator through an offline channel, through a store. And in that time, it was easy to have those one-to-one conversations. So the bank manager, they would typically know their clientele. They would understand the people that came regularly to the branch. They potentially knew people who were retiring. They knew people who were moving home. They were able to have intimate, personalized conversations that allowed them to pitch products and services that were relevant to their consumers, to their customers. But that's very much changed today. If we look at the economy today, it's a global data economy. Gone are just the offline channels, and now we have a whole range of new channels that we're constantly interacting with. We've got the mobile app, we've got the digital website platforms, we've got a whole range of new platforms that allow us to interact with businesses. So what does that mean for the businesses that we work with today? Those businesses have lost the ability to have that personalized one-to-one conversation, that customer intimacy. But actually, if you look at all of the channels that have opened up, what we have today is a whole range of interactions that customers are holding on those channels. And those interactions that customers have are a digital footprint. It's the DNA of the customer. It's a data footprint that the customer leaves behind for the business to be able to leverage. Because yes, we've lost that one-to-one conversation with the customer, but we can use that digital footprint to understand that customer, to understand their needs, to anticipate what that customer needs tomorrow. What products and services should we pitch to that customer? What's the right message for that customer? So very much in this data economy, and businesses realize the value of that data. So if we go back to 2014, the Gartner hype cycle, we saw that big data was very prominent. And actually, every newspaper you picked up, every tech trend or blog that I read, big data, those words were everywhere. Big data was going to revolutionize every business. It was going to revolutionize medicine, every industry. Actually, that didn't quite happen. So if we look at businesses, there's huge amounts of investment that have gone into these big data platforms, into collecting big data. But fast forward to today, If I look at some of the big banks that I work with, the retailers, the telco companies, they're struggling to get value from those investments that they made. So yes, they have those big data platforms, but many of those big data platforms, they find it difficult to get projects into production. And actually, worryingly, one of Gartner's statistics indicates that 90% of those big data lakes, big data platforms, will be useless by 2018. And that's because there wasn't a business focus necessarily when organizations started collecting that data. Often it was a cost-saving IT measure, but also businesses have struggled with the skill sets in order to harness that information. The people who can look at those business use cases, who can translate them into data and analytics, and can work with that data, work with the analytics to create insight. So fast forward to today, and the most recent Gartner hype cycle, we no longer see big data on there. And actually, big data's not moved to the plateau of productivity, it's completely disappeared. And that's because data is data. It's considered status quo. Everybody understands data has value. Everybody understands it needs to be collected and stored. But actually, storing data doesn't create value. It's what you do with that data. So now when we look at the hype cycle, right at the top are those analytical techniques that can help us get value from data. So deep learning, machine learning. We see now when you pick up the newspapers, read in the trends, in the tech blogs, it's all about deep learning. It's all about artificial intelligence, machine learning, and how we can leverage those analytics to get value. I often get asked by the customers I work with, who's doing this really well today in the industry? And arguably, I think the people doing it the most successfully today, in terms of leveraging data and analytics, are the pure play digital elites. It's the companies like the Ubers, the Facebooks, the Airbnbs, because these companies have to be good. They don't have products and services in the traditional sense, like a bank or a retailer would. Their whole business model is based on products built from data. So they have to be good at leveraging data. They're creating the next set of analytical tools that are being used out in the industry. But not only that, what these companies are doing is they're changing customer expectations forever. So think about that taxi ride that you would traditionally have. You would call the taxi and then you would wait, not knowing, not sure when it's going to turn up. Uber has provided so much more transparency into that customer journey. Now, when you order that taxi, you can track it coming to your doorstep. You know exactly when it's round the corner. You can share your trip while you're on that journey, and when it comes to completion, you don't have to worry about having cash on hand. It's an electronic, automated transaction. That's what our consumers expect today. They expect that transparency. They expect that optimal customer experience, not just from these digital elites, but from every industry, every service that they interact with. So that comes back to then, as organizations, as businesses, how do we leverage data? And coming back to my data science background, when I'm speaking to businesses, I'm often saying to them, you know, machine learning, it's not new to you. Actually, we've been doing machine learning for many years. If you look at the banks, they've been building predictive models for many, many years. And there's been analysts that have been around for many years. So if you look at how a traditional analyst would have created, say, a predictive model, you would take your data sets, your 5 or 10 data sets. Often it was transactional data that you would analyze and find those key features or variables that were predicted with churn or with propensity to buy. So if I work for a bank, maybe I'm looking at what's the likelihood that a customer buys a mortgage. So I'm going to look in that data and I'm going to look at, does age correlate with mortgage? Does the number of children a customer has link to mortgage and whether they're likely to take out a mortgage? And by going through that process, I'm going to find the 8 or 10 key variables that help me predict that customer is going to take a mortgage. I'm going to feed them into my machine learning algorithm, and I'm going to have a predictive algorithm. This has been happening for many, many years. But what's fundamentally changed is today, with big data, and not just transactional information, but now interactions, the fact that customers on the website, the fact that they're calling into the call center and you've got voice data, all of this data, it's an explosion of data that the human quant or the analyst or the data scientist can't physically sift through. Potentially now there's 50,000 different variables that describe if a customer's interested in a mortgage. Myself as an analyst, I can't sit and sift through those 50,000 variables. There's just too much data, too rich, too complex for me to make sense of that. So we've got lots of rich data coming through. We know that rich data can help us predict if a customer wants a product or needs a service, but also our business is demanding results from us now. With the rapid change on the market, with the number of competitors, it's no longer possible for the business to wait weeks or months for an answer. They need an answer today or it will be too late. There's another competitor who's already taking your place. So this is where AI, machine learning, deep learning has become increasingly important for our businesses, because it's these techniques that can help us harness those large volumes of data and help us create that insight. And in fact, as you heard in the earlier presentation this morning, these techniques today are able to outperform humans with imperfect information. A machine learning, a deep learning algorithm can now make a better reasoned decision compared to a human because of the volumes of data. But today, these algorithms are not new. When I worked in academia, there was lots of papers that described deep learning, machine learning algorithms for many, many years. What's changed today is we have enough data to feed the algorithms, and we have the compute power to run these algorithms at scale. So let me share with you an example. So I was working with a telco customer, and telco, just like every other industry, often want to be able to predict churn. When's a customer going to leave us? How can we save that customer? Because ultimately, it's easier to save a customer than to try and win a new customer. So a telco would traditionally build a predictive model by looking at variables like how many calls has this customer made? Have they called into their call center recently? How many complaints have they submitted? But the telco wanted to look at the problem in a different way. They said, we want to start looking at customers and their behavior and their interaction. What does that tell us about the customer? So what we did is we took every single interaction a customer had across 13 different channels over a 5-month period, and we integrated that data. So we had every single interaction that we could line up in a customer journey that shows what that customer is doing, what their behavior is. And from that, those interactions, we can begin to anticipate what that customer is going to do. So we see that customers had lots of poor experience on the network. They've been trying to make calls and they keep getting lots of dropped calls. Then maybe they've called into the call center and they're showing that they're unhappy in the call center. We can get that from the voice sentiment from their voice in the call center. And then we see that that customer is actually on our website and they're visiting the terms and conditions page. Suddenly, these 3 interactions together are a really strong indicator of churn. Really strong indicator that that customer is unhappy. So taking 2.6 billion events and trying to find those combinations of 2 or 3 things that might indicate churn is really difficult for the human analyst. We could have spent months sifting through that 2.6 billion events. What machine learning and deep learning in this case have allowed us to do is feed the algorithm the 2.6 billion events, and the algorithm does the feature engineering. The algorithm figures out what's the key combinations of events. As a human analyst, I can only focus on one event at a time. I can count up that event, I can average that event, but actually the machine learning, deep learning algorithms can find those patterns, those combinations. So we actually automate some of that really cumbersome stuff that we, as kind of analysts or data in the data community, would have to do, and we give that task to the machine learning algorithm. This frees up the data scientists, my analytics team, from having to do all of the data wrangling and feature engineering and giving them the time to focus on the actual algorithms, the outputs and the insights, the innovation that we can get from machine learning, deep learning. And it's also hugely beneficial for the organization, because what it allows the business to do is move away from thinking about their business as a static snapshot, thinking about a customer as a static snapshot in terms of demographics, the age, the salary of that customer. Instead, we can begin to look at that customer and their interactions and think about relationships, think about influence of those relationships, think about situations, look at the behavior of that customer. Get so much more insight than we've ever had before. But as we do this machine learning and this AI, deep learning, and begin to do more of it, build more models in our organization and begin to drive more actions from those models, to enable those actions, we have to productionalize. And one of the key challenges in industry today is actually taking that great, fantastic, shiny new model that your data science team has built and put it into production, where it can actually be out there making an action, sending out a campaign, contacting a customer, whatever that action might be. And we see from the research, we see from the companies we work with, that operationalization is a real challenge for organizations, and it's only getting more difficult. So, you know, there's sessions today happening around R and R Shiny. There's all of these new languages on the marketplace. My data scientists are using TensorFlow, they're using Spark, they're using R, they're using Python, Java, lots of different languages to be able to wrangle data, to be able to understand that information. But what those languages, what that complexity means, it's so much more difficult to put those algorithms into production today. But we have to put it into production, because if we look at where our organization's going, it's no longer about trying to productionalize one model, it's about productionalizing at scale. So think about when you do a Google search. When you do a Google web search, there's not just one model running behind the scenes. Actually, what Google do is they look at the time of day. They look at the user who's searching. They look at your location, and based on a whole set of variables, they then give you a set of personalized search results. So potentially, you might have 10, 15, 20 models per customer or per individual in the future. And as businesses move to this point where you've got so many more models in production, we also need to have automated decisioning. Because AI, deep learning, machine learning is not useful if you are not able to now make decisions, and having a human make that decision in that loop is no longer possible. You need the machine to be making that decision. So as we begin to think about putting our models into production, we can think about traditional manufacturing, because essentially in traditional manufacturing, they've gone through the same process of initially creating maybe a product through a chisel and hammer and then putting it on a production line. I had the fortune of visiting the Lego manufacturing plant in Bieland, and it was fascinating to watch these Lego bricks be produced. And Lego know they're a premium supplier, a premium toy brand, and they have to ensure that quality of their product. So if you look at manufacturing with the Lego brick, when they produce those bricks, they put a whole set of measurement around that manufacturing because they want to ensure the quality. So as the brick comes off the manufacturing batch, they take measurements like width, height, and depth to look at the structure of that brick. But they also look at what that brick's supposed to enable, the outcome. So with the Lego bricks, it's all about play for children. So they do tests like bite tests, torque tests, pressure tests, because children should be able to put bricks together, but also pull them apart. We can apply the same thinking to our models, because as we begin to create production environments for our models, we can begin to put that monitoring around those models, the measurement. So we can look at all the statistical measures that tell us if a model is accurate, how many false positive hits is it giving, what's the p-value, all of the statistic measures. But we can also test the outcome, the business outcome. That might be a response rate. It might be how many customers are we able to target. And in this way, what we can do is we can begin to automate all of our models that we're now building, the AI deep learning models, and have them managed by only a few analysts per year. And this is huge because, again, we're creating automation, we're using AI, but we're freeing up the time of our data and analytics teams from becoming maintenance and engineering teams to actually doing innovation. They're able to free up time to focus on the new use case, to focus on the next version of the model that will be better than the last. So a prediction from Tom Davenport here. He predicts that actually one of the functions that will be the most impacted through AI automation is marketing. There's a lot of decision-making in marketing in the future that will be driven through models, through algorithms, through code. And there'll be more machines, more code, than there will be humans in the future in the marketing function. And so this has given rise to lots of questions, also in the news, etc., around what does the future economy look like? If humans are no longer needed, if we're automating those roles, do we need to start taxing the robots? Are we all going to have 4-day working weeks in the future? Sounds fantastic. But actually, it's about a partnership. Because yes, putting these models into production is important, but we need to be checking these models. We need to be actually ensuring that the output they're generating is valid. So yes, AI and machine learning will automate some of that feature engineering, that labor-intensive work, but it frees up the time for the data analysts, the data scientists, the marketeers, etc., to focus on the outputs of that model. We know models can be biased because they inherit the biases in the data. It gives us time to challenge those models and think about the outputs they're producing. So the future is not about the machine and it's not about the human, it's a partnership between both. And if we look back in history, there's a perfect example of this. When the ATM machine was introduced, there was lots of scaremongering in the media. ATM machines were going to take away the job of a bank teller. And to a degree, yes, that was true. So on average, there was 21 bank tellers per branch, and that reduced to 13. But actually, fundamentally, what happened is the branch became cheaper to operate, so banks opened more branches. But also what happened to those tellers is their role changed. So no longer were they just a cash handling entity for doing transactions with customers. They became known as the customer relationship team. They began to focus on the more human element of having those conversations with customers. And this is exactly what we need to be thinking about within each department, business function within our organization. What is the impact of AI and automation going to be? And it's not necessarily scaremongering. Yes, it will replace some jobs, but what other opportunity will it create? We as humans will be, the emphasis on the teaching curriculum, etc., will be on the more human elements, the creativity, the innovation that yet cannot be automated. So in summary, data and analytics is a differentiator, and we see it across industries. We see lots of business challenges being solved through data and analytics. We see these digital elite companies that are completely coming in with data and analytics and being those disruptors. We see that there's new data products that are being created that we never imagined before. But ultimately, in this new future, where it's algorithm and code that are the new billion-dollar unicorns, it is still that human in the loop that will be required to help harness the potential of data and analytics. And with that, I will say thank you. I'm not sure if we have time for a few questions. That's okay. Thank you.